Welcome to another episode of It Depends. I'm your host, Sanjeev Mohan, principal at Sanchmo. Last week at the Snowflake Summit 2022 in Las Vegas, I had an opportunity to catch up with Kent Graziano. As many of you know, he was Snowflake's chief evangelist until his retirement earlier this year. Although he may have retired, his presence was writ large wherever I went. Kent is an icon in our industry. In fact, he has a nickname called the Data Warrior. So I'm honored that Kent has agreed to come to this episode of our podcast. Kent, a very warm welcome to the show.
Thank you, Sanjeev. Great to be here. Honored to be on your show.
Thank you so much. So Kent, you've had a storied career. And can you, before we get started with peeking into your mind and your experiences to help guide us through these turbulent times of data and analytics, can you please enlighten us with your background?
Wow. Yeah, so I actually, I learned to program in high school, of all things, on a Wang computer that had basically no memory, no disk, had to load the operating system, which was BASIC, first, and then start programming. And to save anything, you had to write it out to a disk. So anytime I wanted to run a program that I had written, I had to load it into the memory from a floppy disk. And so myself and my calculus teacher, my senior year, we taught ourselves to program on one of the very, long before there were PCs. This was a desktop, but that worked really well. And that just kind of began the whole thing when I got into college. I studied environmental science. Didn't study computers. Wasn't a lot of computer science programs at the time. So I studied environmental science, but in the process of doing that, worked in a number of labs and found there was a need to write little programs for grad students. And so I developed my skills through college, through the help of a couple of professors, and eventually just worked my way into the computer industry. Not my intention, but that's what I ended up doing, and eventually got introduced to DBase. And then in the late 80s, got introduced to Oracle, or version 5 of Oracle, of all things, long before they had the transaction processing option. And just continued from there. I became fascinated with relational modeling and relational theory and set theory, and really enjoyed solving problems with data rather than writing Fortran and basic programs, which is what I had been doing prior to that. And that kind of went from there. I built one of the first Oracle databases for the Department of Interior, based in Denver, Colorado, and did the first one that had distributed processing, where we had people doing data entry in Washington, D.C., and the server was actually in my office in Denver, Colorado. And that was in the very early 90s. Just went from there. In the middle of the 90s, I got introduced to data warehousing via Bill Inman and his teachings. Got to build a data warehouse for the National Renewable Energy Lab. So I had merged my love of the environment with my skill in data to do some analysis around renewable energy in the mid 90s. Went into consulting from there. Actually, at one point worked for a software company that eventually got acquired by Oracle. And that's where I learned the Oracle case tools, and eventually Oracle Designer, which I helped author a couple of books on that. Worked with Len Silverstein again in the mid 90s when I got introduced to Bill Inman, and he and Bill and I co-authored a book called the Data Model Resource Book, which became a very popular book with template models that people used in a number of industries. Eventually, again, got back into consulting, stayed in consulting for a while, went independent, worked for Denver Public Schools and built their data warehouse program from the ground up so that we could do analysis of what was happening with all the students in the district and help the school principals manage their schools better. And even built something that got written up in the Wall Street Journal a teacher compensation program that was based on performance, called Pay for Performance. It was the first one in the nation. And we built some advanced algorithms with that analyzed what teachers did and made recommendations for increases based on a variety of factors that the school board had agreed on. And then, excuse me, in the, well, let's see, when was it? 2015, I was actually working on an Agile project, building a data warehouse in SQL Server, and was meeting with my team in Denver at the time. Happened to be in town. I had moved to Houston, Texas by then. Was in town and got an invite to attend a big data meetup at the University of Denver, which is actually where I graduated from. And they said the title of this thing was going to be Snowflake, the data warehouse built for the cloud. And I looked at that, and having been in the Oracle world for nearly 30 years at that point, just, you know, somewhat skeptical, to say the least, of what is this thing? It's called Snowflake. What's this thing about the cloud, right? What are we doing? And I went to my very first presentation given by Kyle Rourke, who is still one of the leads there at Snowflake, and Todd Beauchesne, who was one of the first sales engineers. And they just did this, just blew me away in the presentation, what they were showing of, you know, instantly starting up a database in the cloud without having to have a server, without having to have infrastructure, just going in and creating a database, you know, logging in, firing queries off, this idea of being able to apply whatever query resources you needed from a compute perspective, independent of the storage. Talked about this whole separation of compute from storage thing. And that was pretty fascinating. It was really hard to understand because they call these things virtual warehouses. So I was getting very confused between those and data marts. But then the thing that got me was they loaded JSON data into a relational table, into the data type we now know as variant, and then wrote SQL statements to analyze the JSON. And at that point, I had been, I'll say, actively avoiding big data in my career, thinking, how can I make it to retirement without ever touching big data? I didn't want to learn MapReduce, didn't want to learn Java. It's like, I'm very happy with SQL. And here is this guy showing me this demonstration of semi-structured data, which is pretty much what everybody called big data. 80% of big data was semi-structured, and most of it was JSON, and a little bit of it was XML. And they're just loading this document. You know, I was familiar with Mongo at the time. They're loading this document into a table, create table. Okay, I recognize that. Data types variant. Okay, that's a new thing. They load the data in, and then he starts writing SQL statements, and I'm, how is he doing that? That's amazing. I had seen Oracle at the time could already do this, but it was very complicated to do it. Required a lot of special functions. You had to do some special indexing in order. I mean, basically in Oracle, you were querying a very large string, and it was doing effectively substrings to pull it all apart. But this was like amazingly fast. And so that got my attention. I was actually live tweeting during this because I was part of the Boulder BI Brain Trust, Claudia Imhoff's group at the time, as an analyst. And so I was live tweeting at the time going, this is amazing. This Snowflake thing. It's like, we need to all, as an industry, we need to look into this. And I kept following the company, and eventually saw a job posting that said that they needed somebody who could speak publicly about the technical aspects of this product, and give presentations, write blog posts, help people understand the value proposition of this software. And I was like, my wife and I read the job description and we're like, wow, that's written for you. I've been doing that in the Oracle world for free for 25 years, right? Wow. Going and speaking at user group conferences, and and here's somebody, this is the job. This is a job. And so this was the what became my technical evangelist role at Snowflake. I applied for it. Fastest job interview I think I ever went through. Within less than 6 weeks of seeing the ad, I was an employee of Snowflake in November of 2015. And then, I guess we'll say the rest, as they say, is history, and how you know of me and everything that I did in the last 6+ years working as the chief evangelist at Snowflake.
How many people were in Snowflake at the time you joined, approximately?
When I joined, there was, when I saw the presentation, they were debating, it was either 60 or 80 people. And by the time I joined, it was 100. And I did find out my official employee number was actually 103. A number of people had left at the time. A couple of, not very many. But I was the first non-sales remote employee of the company in 2015, because I lived in Texas and was not going to move to California and move to Silicon Valley. So I commuted a couple times a month to meet with the founders and product management and my boss, who was the VP of product and marketing at the time, to learn everything I needed to learn about Snowflake. And then eventually started, traveling, going on the road, giving talks, doing data for breakfast, Snowflake world tours, things like that. And so it didn't matter for the role I was in really where I lived, as long as I was near an airport, basically.
Yes, absolutely. And now it's even more so, like after the pandemic or during the pandemic. Last week when we were at the summit, if we fast forward to 2022, there were about 200 partners who were exhibiting in the expo hall. And some of the companies I'd never even heard about. What is going on in our industry? Why do we have so many companies that are sprouting up so frequently?
Well, I think that basically the cloud has proven to be effective. People are adopting it at a incredible rate. I mean, since COVID in particular, it's just breakneck speed, but it's lowered the barrier to entry, right? If you don't have to have a data center and go through massive procurement processes that everybody used to have to buy hardware and figure out what size hardware you need, all of that, it's a lot easier to get your idea going, right? And there's just lots of ancillary services that are needed. Snowflake, from day one, worked very, very hard at building an incredible ecosystem. I mean, they wanted to be the platform, right, for the data. But lots of things, as you know, that go around it, whether it's the data engineering, ELT, data modeling, report building, data science, all these other tools are on the periphery, but need the data and need the platform to power what they're doing. There's just a huge amount of opportunity. And really, if you've got some good engineers and some good ideas, you can start building a lot faster. And I think that's why we've seen this acceleration of growth, because in reality, you don't have to have millions of dollars to start a company now. Really, we're back to, one person in their apartment during COVID could spin up some resources on the cloud and start building something. And a lot of companies even did that with Snowflake, right? Built apps on top of Snowflake. That's their whole startup challenge, right?
Yeah, there's a startup challenge, and there's some companies I saw that are only on Snowflake, and we'll talk about some of them because I saw you're an advisor to some of these companies, but we'll get to the product after we talk about what's going on in the market. So from your vantage point, looking at what's going on, what are some of the biggest trends these days?
Well, I think the hottest trend for sure is data mesh, which I know we're going to talk about that a bit. But data mesh, AI, and machine learning seems to be that's really coming to the forefront now. I think.
What part of AI, machine learning? What aspect of it?
Democratizing it. That with the power that we have in the cloud now and the ability to have basically near unlimited resources, whether it's the storage necessary for the amount of data for appropriate machine learning, but the power to process through it. In the early days of AI and MIT working on all these things, I mean, you basically needed a supercomputer, right? Which would take up, a massive amount of space and costs millions and millions of dollars in order to effectively churn through the amount of data necessary to produce anything like artificial intelligence. That's gone, right?
Yeah.
And so there's just so much more opportunity there. And then with the democratization, getting new tools in the market so that you don't have to be a PhD statistician to actually achieve some of these things. I've looked at some tools that, they've got all the algorithms, I'll say the standard algorithms that a statistician would know are built in, and they're just named. And you have to understand the purpose of those algorithms, but you don't have to mathematically know how to do them yourself. You can start feeding data into those algorithms in order to see what the outcome might be.
Yeah. So this is great. So you mentioned data mesh, AI and ML. So I want to do a little bit of a deep dive on data mesh, because I talk about data mesh quite a bit. I love the concept, but I'm a bit confused. The entire premise of data mesh is decentralized architecture. One of the principles that Zhamak has is self-service data infrastructure. Yet I see a lot of people saying, we believe in everything, but we're going to centralize on Snowflake. That is our one single source of truth, if you may, for our data. What are your views? We are centralizing the persistence layer and now the development layer as well with the new pieces, and yet data mesh is decentralized.
Right. And so two things. One is, as Zhamak says, it's a socio-technical framework, right? So it's not just the technology. So we can have a lot of aspects of data mesh are really organizational, and we can spend a lot of time talking about that. I don't think of it. I've worked with a number of customers who are building data meshes in Snowflake, and I don't think of it. They're not centralizing on Snowflake. They're standardizing on Snowflake as the data platform, because if you look at the concept of the data cloud, early on, SnowGrid, which is the connectivity within Snowflake that allows you to work with data between different regions in the cloud, but also different clouds themselves. Oddly enough, Benoit at that point called it a global data mesh originally, and then had to change that term, and it's now called SnowGrid. And when you look at the ability of Snowflake to do cross-cloud and cross-region replication and cross-cloud and cross-region data sharing, it is decentralized. And so it is giving the companies the opportunity to empower localized domain data teams, potentially with their own Snowflake account. So they got their localized governance, so you've got the federated governance. They can put in all of the security and masking rules and everything, but they're still within the data cloud, so they can easily share that data with other teams, which is part of the interoperability aspect of data mesh. So they're not centralizing everything into necessarily one Snowflake account, but they are standardizing it on Snowflake and the interoperability built within the data cloud in order to enable a global data mesh.
I see. By the way, I have to mention something, a rant of mine. So I have this thing that I've talked about in some conferences called the tyranny of jargons, where we have all these jargons that we keep coming up. So I find socio-technological aspect to be one of those. This is my view. Socio, in my mind, is a people and process. So if you see socio-technological, it is nothing but the good old people process technology.
Absolutely. You're 100% correct.
But if somebody says, yeah, we should consider people process technology, we go, I'm sorry, that's trite. We don't want to talk about it. That's old. So socio-technological sounds a lot more,
a lot more sophisticated.
Sophisticated, yes.
Yes, yes. But, and really, like with Roche Diagnostics, the hard part of what they did wasn't the technical implementation in Snowflake. It was getting the organization set up with the domain data teams and getting that data ownership, right? Getting what we used to call data stewards.
Yeah.
Who owns the data? Who's responsible for the quality of the data? And I think that Zhamak's framework is helped, I think, put that into probably crisper focus. I mean, you and I have been in this business for a long time, and we've been trying to do this for 30 years, right? And it comes and it goes, and only the largest organizations, whether it was master data management, data governance, all of these different approaches, but in reality, it's very rarely been successful. I think now, and in part is because we didn't really have the technology to make it work well. We've talked about federated data warehouses for, again, probably multiple decades, but making that work was a technological challenge. The data cloud has, in my mind, solved that technological challenge. Again, remove those barriers. Yeah, it's much easier to do. I mean, the infrastructure is built in, whether it's through the Snowflake's data marketplace or the basic data sharing features, the ability to build a private exchange within an organization. Those are all the technological pieces that are necessary to implement this data mesh decentralized framework, have it standardized,
right?
Making it easy so that the domain team, which are ostensibly subject matter experts from the business, don't have to be technology gurus in order to make it happen. And they don't have to have an entire IT department to make it work. And I think that's the thing that's changed, right? I think it's a great concept. Does everybody need to do data mesh? Absolutely not. Right. And that's like with everything in technology. You need to do the analysis and say, what's the cost benefit analysis here? Do we really need to do that? Or are we a small enough organization? We just need, one Snowflake account, maybe need 3 or 4 databases within the account. And we have a small IT team, and they're able to handle all of this. Part of the problem she was trying to solve is the bottleneck in monolithic data warehouse operations, which was always the IT team, having to onboard the data and transform the data and get it ready for somebody to consume. That, if you've got a very large organization and multiple departments with multiple sources of data and only the one IT team, they could become a bottleneck. And so the decentralized approach really helps solve that, provided it's put together properly. But it's not a snap of the fingers and say, hey, we're doing data mesh, any more than Agile was, that you could say, hey, we're going to become Agile, we're going to deliver things in 2 weeks. It's like, it's not quite that easy.
So talking about multiple sources and getting data and the rise of data lakes, I have a feeling when I started my career, ERD, enterprise ERD diagram using Irwin was an extremely important part of my job. But somehow I feel with the rise of modern technologies, we are kind of brute forcing our way into the modern architecture, then we forgot the necessity or the art of data modeling. You spent decades on it. What are your views on data modeling?
Yeah, I have. It's amazing over my career, the number of times I have been on panels where someone asked me, so do we really need to do data modeling anymore? And, the first time that really started was back when big data started and Hadoop, where people started talking about, we're going to do we're going to build, before they called them even data lakes, we're going to have all these this unstructured data, and we're going to do schema on read and all of these things. It's like, oh, we don't, we're just going to load the data in. Well, a lot of people did that. They loaded the data into their Hadoop infrastructure, and they ended up what we now refer to lovingly as the data swamp. Is all the data went in, but hardly any of it came out because they suddenly realized nobody knew what was there. And the horror stories of data scientists going, oh, that's great. They've given us all this data, but now we spend 80% of our time trying to figure out what the data is and where it is. And then, mapping the different files to each other and figuring out where's the relationships. What's that? where's the relationships between the data? Sounds like a data model to me.
Yeah.
I even, it happened, of course, with NoSQL as we evolved in the NoSQL world. And we talked about doing schema on read. I wrote a couple of articles and an ebook on this a while back for Snowflake. Is like the term schema on read includes the keyword schema.
Schema, yeah.
Right. And what's a schema? A schema is a model.
Yes.
It's just a different term for a model. I mean, people think of it as a database thing, but really it's the design. If we can't discern the pattern in the data, the schema, then we can't use it, right? We can't make sense of it to derive any value out of it. So we still need data modeling, and it is starting to come back. I think with early on in Snowflake, there were certainly many customers, and lots who still do, took advantage of the schema on read aspect of Snowflake with loading JSON data into the variant and all of that. But in the end, they built views on top of it. What are those views? Those views are a model that help express the content of that data, because if we can't express semantically the content of the data in terms that the business can understand, they can't use it to drive business decisions, right? And so I think over time, again, we're going through, I think, another cycle of where, yeah, we can brute force it, we can load all this data in, and we'll just figure it out as we go. And I think that works great if you are a small organization. If you've got one source of data and you're not trying to integrate data across multiple sources, as soon as you're trying to integrate data across multiple sources, what we basically did in data warehousing, all the things that Bill Inman wrote about, you need to understand the content, which means you need to understand the model and the structure of that data and the meaning of that data. So it's, in order to properly integrate it, you have to be able to see how that goes. And you just can't do that on the fly constantly. And you can do it, that's how you do data discovery. You know, you may go in and do some schema and read things to figure out what's there, but ultimately you've got to be able to articulate it. And interestingly, that is part of data mesh, is making the data discoverable and understandable. So that means having a data dictionary. Having a data dictionary, in my mind, means you need to understand the model of the data. Do you express it in a diagram, in an entity relationship diagram? Maybe yes, maybe no. It just depends on the context that you're dealing with.
Right.
Even you talk about like knowledge graphs. People like looking at knowledge graphs now. And what's that? That's a data model.
Yeah.
So I think it's,
Yes.
I think we're coming back around to it.
Coming back around, yeah.
Yeah.
So talking about, you know, also it ushered in this era of open source at a massive scale in data and analytics. What are your views about open source?
Well, I'm not a huge fan of open source. I think there is a place for it. And the reason I'm not a big fan of it in general is because most of the organizations that I work with tried to adopt open source. They did it for the wrong reasons. They did it because it was free, right? That they didn't have to pay for the software, but they paid for it in different ways. Primarily the cost of human resources, that it took a lot of knowledge and time to often make the open source software do what you needed it to do. And so I think there's a total cost of ownership conversation there that, you know, when you're getting into something like using open source, as an organization, is like, why are you doing it? If you're doing it for cost avoidance, it's probably just a bad idea. You're better off going with a vendor that has support and, you know, I'll say the software is hardened and does what you need it to do, so that your business people can take advantage of the data and do the things you want to do. You know, like I said, in some sectors, you know, there's certainly a need for open source. Folks that had large engineering organizations that had very specific things they needed to do. I remember early on, one of the CIOs I was working for asked me to look into, you know, how was, I think it was it Facebook? Yeah, Facebook and Google, they're very curious, and Amazon, how are they doing what they're doing and having queries come back at the speed of light? And what I discovered was they had massive server farms, and they had teams of PhDs from Stanford that were working on the core, on the engineering core of this open source software to make it achieve those goals. And that's something, of course, many organizations weren't going to be able to do. And so they were able to achieve great things, but at great expense. And they could afford it because that was part of their business. And so I think it has to be done very judiciously. Snowflake has participated in a number of open source communities and is contributing to those open source communities and evolving it. So it's like you said, I've never been a big fan myself because I'm not an engineer. And with most of the organizations that I'd worked with in the past, they really needed solutions that worked out of the box. And their money was better spent in solving the business problems than it was solving low-level engineering problems.
Very true. Yeah, very well put. Ken, going back to the topic of data modeling, so I'm gonna more like pivot into some technological. So we want to talk about the companies that you've chosen to advise. Before we go there, you are a certified data vault practitioner. What is data vault? Why should we consider it? How is it different from other?
So data vault is a particular methodology and approach to designing data systems. It was invented by Dan Lindstedt, published first in 2002. So it's actually been around for 2 decades now, which some people still find surprising that they hadn't heard of it. And it was designed initially for data warehousing in order to solve some of the technical engineering problems we had in trying to build data warehouses in an ever-evolving landscape where, if you're using third normal form modeling or dimensional modeling, they both have their places and they have very good uses. But if you're trying to evolve a platform, they're very hard to change once you've got those models in place. If you're doing a third normal form type model and you miss a relationship and you've already built the database and you've loaded a bunch of data in, and now of course today we're dealing with terabytes of data rather than megabytes of data that we used to deal with. If you have to change that, you've got to change a table and add a foreign key and add some additional attributes. Re-engineering and reloading that table can be very time consuming. Likewise, in a dimensional model, if you have a conformed dimension and you've got new sources and new attributes, and you say you've already got a 500 megabyte dimension, to take that down and reload it takes a lot of time. It takes your system offline. And at the time, Dan was seeing these things. He was dealing with terabytes of data in the defense industry, and finding that they were spending more time re-engineering the model as they got new data and discovered new requirements. Things like, oh, hey, they want to do analysis by something they never mentioned before. Well, in a dimensional model, that means you need a new dimension, which means you need to redo your fact table, which means you need potentially a different level of granularity. You're going to have to reload all that data, assuming the data is still available to reload. Before, we had data lakes where we stored everything. Very time consuming, very expensive, and the cost curve went up. So he went about trying to come up with a mathematically more refined way of modeling the data. And he came up with the what we call data vault now today, with hubs and links and satellites. And in talking with CJ Date a number of years ago, trying to figure, it's like, from a normalization perspective, what are we really talking about here? And CJ looked at it and said, well, your hubs and your links are just keys. So that's effectively, it's 6th normal form, and your satellites are 3rd normal form. So it's highly normalized. I mean, we're down at the atomic level of the data, the lowest level of grain possible. So we can just load the data in, and it's very easy to change. You discover a new relationship in Data Vault, you're building a new link between hubs, right? You discover a new subject, object, whatever you want to call it. Well, that's a new hub. You get new source systems for things you already have. Say you've got customer already modeled, but you got a new source system with additional customer attributes. Well, in the case of Data Vault, you add a new satellite onto your existing customer hub, You don't change anything that's there. It's all additive. And so it makes it much easier to evolve it. So it's an agile modeling technique, as it turns out, even though when Dan came up with this, we were just barely starting to talk about agile. But in the end, it turns out to be a very agile modeling technique that has proven very effective in designing and building out very large data platforms, but in an incremental manner. So it does allow you to be agile and figure out what are the real business problems to solve today, what sources do we need, and build it out a little at a time, rather than what we used to do before, which was boil the ocean and do a massive, as you mentioned to Erwin, and you working with Erwin in the past, a massive enterprise model.
It's a multi-year data warehouse project.
Multi-year, just to get the model done. And then, by the time you deliver it, well, the company might have been acquired. It might be different source systems. It may even change businesses at that point. And then the model is only marginally useful, and you're back to the drawing board.
So true to your evangelist roots, you explained and convinced me about Data Vault. So that's excellent. Thank you so much.
Yeah, I'm actually, I tell people I've actually been a Data Vault evangelist, long before I was a Snowflake evangelist.
I see. Yes. Yeah. And it seems like a lot of Snowflake deployments are built on the Data Vault concept. Correct?
Yeah, there is definitely a large percentage. I mean, I spent at least half of my time in the last 2 years, 3 years, I was at Snowflake talking to customers about Data Vault. They figured if they're going to this new platform in the cloud, they felt that, well, there must be a better way to design things, that people have learned things in the last couple of decades. And I would get talking with them, and basically they say, well, yeah, what we were doing, okay, it worked. And they would list basically all the things I just told you as to the issues they were having. And then, what goals do they have? Well, we want to be more agile. We need to be able to adapt to change more quickly. And we haven't been able to do that with these other modeling approaches. And they actually were doing things like Googling agile data modeling. And it came up with actually the blog post I did for Snowflake a number of years ago about Data Vault. And using that term agile data modeling. And so they looked into it, and many organizations, large and small, decided that was the way to go, that was going, as they moved into Snowflake, that they were going to adopt this new approach. In fact, I mentioned Roche Diagnostics doing data mesh. They decided, the modeling technique they're using for their data mesh is Data Vault.
Oh, wow. I didn't know that. Okay.
Yeah. They decided to use a Data Vault approach for building out the underlying data products within their data mesh, because it is easy to add to it and build it more incrementally, which makes it easier on the data teams.
Makes perfect sense. And so in your newfound freedom, sounds like you're busier than ever. So you advise a bunch of companies. The ones that I spent some time learning about were DataOps.live, Coalesce, and SQLdbm, which I don't know too much about. So can we go through why did you pick this? What is so different, innovative about these companies, starting with DataOps.live?
Yeah, so DataOps.live was founded by Justin Mullen and Guy Adams, who I had met through their original company, which was Datalytics. They were the first Snowflake consulting partner in Europe. And I had spent a fair amount of time with them when I was going back and forth to London quite a bit for about 1.5 years, helping customers there. I spent quite a bit of time with them, and they were very, very knowledgeable on the Snowflake platform. And at one point, one of our meetings, they asked me, I said, so Kent, what do Snowflake customers need? What are they asking about that might not be inherent in the Snowflake platform? And so, well, the constant conversation was CI/CD and DevOps. How do we do DevOps with Snowflake in a Snowflake environment? How do we get to continuous integration, continuous development, things like that? And I had met a gentleman a number of years earlier who had started talking about data ops, and data ops being, the application of DevOps principles and Agile principles to data. And, can we do the same thing? And so in that conversation with Justin and Guy, Guy has this, 20-year background in software development. He's like, oh, this makes perfect sense, of course. And so we started looking at, well, there was a DataOps manifesto already. We looked into that and we decided, working with Wayne Eckerson and Mike Ferguson, to take that to the next level. And first we came up with the philosophy of what we call true data ops. Manifestos are great, tell you what we're trying to do, but how do you do that? And so the group of us worked out, what are the problems we really want to solve for data customers, in particular Snowflake customers. So based on some of the experience I had working with Snowflake customers, Guy's experience in the software development world, we came up with true DataOps.org, which lists out the philosophy and the 7 pillars. And then what we did is we realized that with Snowflake as a backdrop, they could actually build software that allowed people to do that. We really wanted, the goals of self-service. CI/CD was just part of it. Being able, implementing automated regression testing, critically important, always done in the software development world, rarely done in the data world. Always kind of a secondary thought. Needed to be well governed. So we needed, trying to balance agility and governance. And, the guys took those ideas and they went and they built this product, DataOps.live. And eventually they actually sold off Datalytics and spun off DataOps as an independent company. And so I had been helping them in my role as the evangelist at Snowflake and as a sort of a mentor to some of our technical partners. And so when I retired, they said, hey, we'd love to have you be on our advisory board and help us out because you know what we do, you understand why we do it, you helped us evolve the concepts. So, and that's why I went with them. Some of the things that they can do, like branching and merging of databases and schemas automatically. And that actually uses zero copy cloning and time travel in Snowflake under the covers. So this is one of those products you kind of referred to earlier. It works only on Snowflake. The fundamentals of the product require that functionality to make it easy, because in prior lives, and this again a feature of Snowflake I always love, is the zero copy cloning. You could never get anybody to give you enough disk space to have a QA instance of your data warehouse that was the same size as production, which means you could do all the testing and performance tuning you want in QA. It would go to production and it would still potentially not work because the volumes were so much greater. Zero copy cloning in Snowflake allows you to test production size loads. And then you take the true data ops, and the data ops software now allows you to say, hey, I need a dev instance. And a couple of clicks, and it does under the covers is doing zero copy cloning. And now you have a branch of your production database to start doing development on or start doing QA on. And it really empowers customers to really work in a very well-governed approach, a repeatable methodology, and achieve all these goals that people want with their data, and really enables what we, again, what we call true data ops. So that's why I'm working with them, helping them evolve the platform and basically evangelizing this true data ops approach.
Which is
really,
yeah.
I think it's necessary, especially in the data mesh world. Turns out it's very, very appropriate. Again, back to Roche Diagnostics. I hate to keep going back to them. Yeah. They're enabling their whole data mesh thing using DataOps.live.
Wow, very interesting. And where does Coalesce fit in this picture?
So Coalesce is, if anybody looks at my writings, I've always been a massive fan of automation. Going back to my days with Oracle Case and Oracle Designer building transaction systems, to be able to do that in the data space. So Coalesce took a page out of Snowflake's book and decided to reinvent the data engineering space for the cloud. And so they created a product from scratch. They're Their founders are veterans from a data warehouse automation company. And they said, well, let's look what we learned from Benoit and Thierry. Let's not take existing code and try to rewrite it. Let's just start over. And so they did. And so what they have built is a product that really does the T part of ELT, right? If the data is loaded into a Snowflake staging, data lake, whatever you want to call it, they take it from there forward in doing the transformations in a GUI environment. Really a no-code, low-code environment that generates native Snowflake SQL under the covers, which of course you can see, and runs natively in Snowflake. And again, this is another one that's built specifically on Snowflake today. And it is making it much easier for people that are more, I'll say, data analysts, maybe even business analysts, to help define the data transformation process without having to be a data engineer. And I think this goes really well with the data mesh concept of having these domain data teams, because you've got more business people and data analysts around than you do have data engineers. But you've got to transform the data, you've got to cleanse the data in many cases, you've got to reformat the data for different use cases, whether it be for data science or for advanced analytics or something of that nature. And they've built a product that allows you in a very graphical way to build out these transformations using this node concept. It allows you to do user-defined nodes, as they call it, so you can have your expert data engineer build templates. And again, the standards, right? Build templates of how we want to build things. They've built things for Data Vault, hubs, links, and satellite templates that people can go in and say, okay, here's the source, and just tie it up. And it generates all the Snowflake code to build the tables and load the tables without anybody having to write any code at all. That's, again, one of the reasons that I'm advising them.
So a lot of data transformation tools require some coding, whether SQL or Python, and they're built for engineers, either data engineers or analytics engineer. But Coalesce is changing the game and saying we should enable the business users, because they're more business analysts than they're data engineers. Is that?
Yes, yeah, that's exactly correct. And I think it's democratizing the approach to data transformations.
Right.
It's one of the things I found discouraging over the last decade or so, is where I had worked with so many things that we got to these 4GLs, even the ETL tools and the BI tools, and then to see, I know it's very powerful using Python and all that, and there's definitely use cases for that. But getting down to people having to write command line code to do transformations. And again, if you have a great engineering team and that's the way they think, awesome. But if you're building an organization and you're growing an organization and you have people that are more analytic or architect in nature and think in terms of patterns and design, they don't want to be doing command line code and learning YAML scripts and Python and Java. Like I said, there's a place for that, but I think there's a definite niche here for Coalesce to fill, to help, again, democratize the approach to data in the cloud.
And what about SQLdbm?
It's a data modeling tool.
I see. Okay.
Yeah, I mean, they are. I've been working with them again from very early on when they first came out. They're a cloud-based collaboration data modeling tool, and they're expanding beyond that rapidly. And so they've added a lot of features over the years to include, like, data. They added a new feature recently for data lineage, that if you're looking at a view, it'll trace through the models, so you can see where all those data elements came from in the model. So you can actually have a great data model lineage. It generates native Snowflake code. They support a number of other platforms as well. But I'm very excited about them because it is a cloud-based data modeling tool, and making it, again, easier for people to go about it at using a modern SaaS methodology, a SaaS pricing model. And I think that's great for people to be able to do that. And they're huge Snowflake fans. they approached me very early on when they were starting their partnership with Snowflake years and years ago. And it's been great to watch them evolve. And of course, if I have a data modeling company wants to have me as an advisor, obviously I was like, okay,
I know.
yeah, I think that's a pretty good fit.
Yeah, it seems like you've come a full circle. All the things you've been passionate about, automation, standards, data modeling, cloud, data mesh, so they all sort of, they've all come together.
Yeah. It's pretty exciting, and I'm getting to work with companies that are, promoting the same things that I believe in as an approach to data.
Yeah, so talking about your passion and your love for all these things that have come together, if you were not doing data, what would you be doing?
Yeah, well, so I have been a martial artist for over 40 years. So, and I have taught martial arts pretty much that entire time. So I would probably would have run a dojo prior to retiring. Would have been interested in doing that. And then outdoors activities, I kayak, I like to hike, all of that. And then I volunteer quite a bit. So yeah, not doing data. It's like I had asked myself that question last summer as I started contemplating, maybe retiring from all of this. What am I going to do with my time? My wife was very interested in, what are you going to do with your time? So I actually volunteer at our church's food pantry most mornings. We have 3 days a week that we actually distribute food, and another 3 days a week where we're preparing to distribute food and doing the intake of all the food that is distributed, and serving. Oh, geez. Our biggest set we do on Saturday mornings, we had served 274 families one Saturday morning. See cars come through. Wow. So over 1,000 people, feeding over 1,000 people. And we're doing hundreds, 400 plus families a week. It's the largest food pantry distribution in the county where I live here in Texas.
And where in Texas are you calling from today?
Well, today I'm actually in Galveston. I'm on the island, Galveston, Texas. Normally, I live up in the woodlands, which is where the food pantry is. But unfortunately, I picked up COVID I think at Summit, and so had to isolate from my family for the week. And as my friends say, there are worse things than having to isolate at the beach.
It'll be Galveston.
True enough. It's not bad as these things go. Thankfully, my symptoms are gone, and I've now tested negative. So I'm raring to go again. But yeah, it's lovely being able to spend time at the beach with me and my dog, actually.
Oh, wow. Very nice. So in your years of being in data management, what are some essential principles that you see work and what does not work?
Collaboration. That seems to be what works, is really working as a team. I used to have a mantra with my team: is we succeed or fail as a team, when I was managing a data team in Denver. And that worked really well, but it was not, it's collaboration as opposed to consensus. The thing that I saw that didn't work when I was in a couple of large corporate organizations is consensus. If we were waiting for 25 people to come to an agreement, that can take a very, very long time. And while the attempt is to make everyone feel empowered, that's great, but we're also not making a lot of progress. One of the CIOs I worked with years ago helped me with a decision model where we agreed at the beginning of any group decision that was going to be made that if we could not reach consensus by the end of the meeting, then there would be a decision maker who would then make the call. And as a team, we agreed that we would go with the decision that was made at the meeting, and we would all support it 100%. And then we would revisit the decision at some point in time in the future. Usually it was a couple of weeks. We would revisit it to make sure, did we really feel like, yeah, is this indeed working out to be the best decision? Or do we make a minor course correction? So we had the collaboration, and part of that collaboration was the agreement that if we couldn't reach consensus, we would abide by the decision of whoever we had essentially deemed to be the decision maker.
I see. What advice would you give to young professionals who are now getting into this space?
Find a mentor. You must find a mentor. Things change and evolve so fast, and there's a lot of knowledge out there. And there's a lot of experience out there. No need to reinvent the wheel. As I say, learn from other people's mistakes. Figure out who in your industry has done or is doing things that you're interested in, and you need to follow them. And one of the advantages we have today that we didn't have when I started is social media. Between LinkedIn and Twitter and the other platforms, you can more easily connect with people who you may not meet in person right off. But then you need to go and attend meetups and conferences like Snowflake Summit to meet people in person, and get to know them and build a real relationship with them, as they say, IRL, in real life.
Yes.
Right? To not just know people through a Zoom screen or through a Twitter feed or through postings on LinkedIn, but everyone needs to learn from others, right? And you need to be, as I was just advising my nephew earlier this week, you need to advocate for yourself in this life and in building your career. But to do that, you do need mentors who can help advise you on the best way to go about doing that.
Right. Very nice. Well, thank you for those words of wisdom, encouragement. How do you keep up with changing times, all the new developments?
Mostly through Twitter and LinkedIn, really, and trying to go to conferences occasionally. Obviously, with COVID here the last couple of years, we weren't able to do that. I found doing online events somewhat tedious, and it's great. You could hear some things. So mostly through more reading articles and blog posts has been more of what I've had to do. But I much prefer attending live events and talking to interesting people.
That is great.
To see what's going on.
Yeah. So Kent, as we come to the end of our show, I'd like to end by asking fun stuff like, what do you do? Tell us something about yourself the world doesn't know. You talked about martial arts, but I think you have a vast history, like 42 years of martial arts. You've lived in Japan. You're eighth black belt, eighth Dan in Taekwondo.
Yes, that's correct. Yeah. I managed to reach the grandmaster level in Taekwondo here, actually during COVID. But yes, 42 years of traditional, I call it traditional Taekwondo as opposed to Olympic style Taekwondo. My grandmaster was actually a personal student of the founder of Taekwondo in Korea. And I was fortunate enough at the University of Denver, he was the Taekwondo master at the university, and I joined the Taekwondo club there and got to train under him for a couple of decades before I moved to Texas. I lived in Japan in the mid 80s for a year teaching English. So I was actually teaching English conversation in Japan. And while I was there, I took the opportunity to train in judo and aikido, as well as I had to study Japanese language. I took private language lessons twice a week for a year and was able to, converse somewhat by that point, enough to understand basic things, because I had to go pay the rent and pay the power bill and go to the grocery store. And the part of Japan I lived in was on the west side of the main island. Very few people spoke English. Or spoke it well. which is why we were there doing English conversation lessons to help people that wanted to learn to speak English better. So I did get the opportunity to study the traditional Japanese arts while I was in Japan. Eventually, when we returned to America, I actually got involved in Tai Chi and have done various forms of Tai Chi and Qigong for a couple of decades now as well. And a form that I greatly enjoy called Combat Hapkido, which Grandmaster Pellegrini, who created that, he was a Taekwondo master as well. He said he knew he wanted to something he could do as he got up in years where, you know, doing high kicks and jump spinning things was just probably not going to be physically feasible. And so he evolved this modern art of combat Hapkido, which is based on traditional Korean Hapkido as well as some Taekwondo and basic self-defense. So I've done, I enjoy that a lot. It enabled me, my involvement in martial arts enabled me to really kind of keep the work-life balance in that. Since I was actually teaching quite a bit for years and years and years, I could never work 16-hour days at the office because I had to go teach my Taekwondo class. And so that really helped me keep everything in perspective and stay physically fit, which was important for those of us who sit on our butts all day in front of a computer.
Yeah, no, the great points, really good points. So I really want to thank you. This has been amazing, just getting to talk about various aspects of your life. And once again, thank you so much for joining us today.
You're welcome. Thank you for having me.
Thank you.